Hello and welcome to a new video. I will show you how I solve the small problem drilling hinges for all these doors. These are some cabinet doors that I'm going to paint, and I wanted to drill holes for hinges on them. And you might ask yourself, why this video, why about drilling just a couple of holes? Well, for me it's very important to be able to modify everything very fast, because as I've shown you, I had a lot of boards with various dimensions, and I had to make the modifications fast. If you are in this situation, it will be very useful to know how to make everything work smoothly, work fast, and of course get good results in the end. I want to thank everybody that's supporting me through my Patreon page. There you will also find the file that I'm using in this video, and you can watch all the videos that I have on my channel. You can watch them on my Patreon page without any interruptions. Of course, the most important part is the support. Thank you all for that, and now let's get started. Let me move this pieces of MDF away from the table. And now I have just one door here. I'm going to flip it over. It has some rounded corners. As you can see, I have installed these two guides on my CNC table. They make it a lot easier to just place the door here, swipe it, and then I will fit a clamp here. After fitting that clamp, you can start working. That is why I use this system, because it's very fast to switch between the boards. I have the board placed here. I have the coordinates of the machine correctly set to this corner. I just need to go to FreeCAD, and here I have this file where I have the door defined and some parameters. It's a VarSet. It's a new type of tool in version 1.0, and here I have all the parameters of each door that I want to mill. Now let's measure the board so I can know exactly where to place the holes for the hinges. It's a 65.7 millimeters long board, so let's go to the computer and set the length to 657 millimeters. And now I select the job, click on the post-process button, save the file. I have already set the file name and the location, so I just go to the Universal G-Code sender and I will open the file. Everything seems okay. Let's press the start button to send the G-Code to the machine and see what happens in the end. And now let's take a look at Universal G-Code sender. You can see here I have a total running time of 1 minute and 54 seconds, which for two holes, for two hinges, both the main hole and the small holes for the screws, for me it seems very fast. I'm not sure I could have done it that fast, and of course not that precise using hand tools. So now you've seen how easy it is to make a set of holes. Let me show you how easy it is to switch the board and to change all the dimensions, to export the new G-code and to use it for the next board that I'm going to mill. I will unscrew the clamp from the back of the board, and now I can just pick up the board, make sure I don't break the tool bit. Take the next board out of the stack, place it facing down, of course, align it to the two guides and tighten the clamp back. And now let's measure it again. It is a 52.7 centimeters long board. So let's go to FreeCAD. Let's go to the parameters, set the length to 527 millimeters. Click away, and as you can see, everything updated accordingly. Let's post-process the job, which means export if you ask me. Replace the file, and now when moving back to Universal G-Code sender, you will see the file updated. I can just press the play button and I will mill the holes for this door accordingly. Now that you've seen how it works, let me show you how I designed this file in order to be able to efficiently modify the dimensions I can also modify the dimensions of the holes, the positioning of the holes, if I'm using different hinges. In this video I'm using European type hinges, of course I'm European, but if you're using different type of hinges or different dimensions, you can adapt them immediately by just changing a few values in the file that I'm using. Let's move on to the computer and I will show you how to make this file and how to use it, how to export the G-code to make everything quick. I'm in FreeCAD 1.0, I'm using the long-term support version. Let's go to the part design workbench and create the model for the door. It's going to be a very quick modeling, just a simple board, so create a new body. Let's rename it, press F2, and I will call it door. And in order to have a 3D object in FreeCAD, I need to draw its projection on any plane that I want. So I will create a new sketch and I want to draw its projection on the XY plane. Draw a rectangle starting from the origin. Don't start from anywhere else because it will create some problems later when creating the job. So start from the origin in the positive X and Y. Setting the dimensions right now is not important. I can randomly click anywhere and close the dialog for creating the sketch. After doing this, I need to make a path to convert this sketch into a 3D object. I can click on this button and leave the default values because I'm going to modify them a little bit later. And let's close this dialog, let's leave the path as is, and I will show you how to create the parameters. Remember that this approach only works in FreeCAD 1.0, so if you are using an older version, this won't work, you have to have a different approach. You can find an example of that on my channel, an older video about making parametric modeling. And of course, if you want to learn more about parametric modeling and you want a one-on-one session, you can find various options on my Patreon page to book some online sessions so I can show you how to do certain things. Now let's create the parameters, which is going to be a variable set. I have this button here, create a variable set. After clicking the button, you can see here I have the variable set created and I have this dialog to add properties. I'm not going to do that right now because there's something that I like to make a little bit different. That is not really important, but that's the way I like it. So I will click on the cancel button. As you can see here, the variable set is called VarSet. I like to call it parameters. I cannot rename it. I will only change the label, not the internal name, as you can see here. So I need to make something different. I will take a look in the Python console and where I see the add object here, copy the line, paste it here, and instead of VarSet I will write parameters and press enter. Now I have two objects, one that is called VarSet and one that is called parameters. I can delete the VarSet object and work on this one. After selecting it, I can see here in the data tab that I have no parameter, so right click add property. First modify the type. I'm using length for this project, so if you have a different type here, change it to length. The group has its name from the previous version of the file, the one that I've created before making the video just to test how everything works. But you might have a different name here. I will first set the parameters for the door, so I will call the group door. Of course, if you want, you can use multiple words in the naming, but what you need to know is that if let's call it door parameters, I won't use a space. I will just use uppercase for each word. And now I have to give a name to the variable. I will call it length. And if you want, you can write additional information for anybody that might want to use the file later. I'm not going to write anything here. I think it's self-explanatory. Click on the OK button, and now I have this variable here called length. In the group door parameters, you can see it written here with space. So remember, don't use space when creating the variables or the groups. Just use uppercase for the first letter and FreeCAD will automatically separate them into words. Now right click again, add property again. I will use the same group, write width, do the same for the thickness. And now I have the three variables that will define the door that I'm going to create. Let's set a length for it. Let's give it a value of 500 millimeters, a thickness of 18 millimeters, and the width of 250 millimeters. Since I'm going to place the board like this will be the length and this will be the width. So let's modify the sketch to use these variables to determine the shape of the sketch. Open the pad from this little arrow, double click on the sketch and select this line, press L for a length distance constraint. In this pop-up I'm not going to write anything, but I'm going to press equal to enter the expression editor. In the second pop-up I'm going to start writing parameters. Press the arrow to avoid writing the entire word. You can see a dot appearing, and now I will start typing length. Again, I can press on the down arrow and select the value, press enter, close all the windows by pressing enters, and you can see I have a constraint here for the entire length of the board. Do the same for the width, but this time I'm going to press I for a vertical distance constraint, press equal, parameters and width. Now I have the sketch fully constrained, you can see here, so nothing can move unless I modify these values. Click on the close button to close the dialog for editing the sketch. And now I still need to change something, which is the thickness of the board. In FreeCAD it is called the length of the pad. So double click the pad and here again press equal. If you don't want to press equal, you have this little icon here. If you click on it, it will also open up the expression editor. So start typing parameters and thickness. Now I have the shape, the model that I'm going to drill fully constrained. It's perfectly determined by these three values here in the parameters. Let's change some of them to make sure everything is okay. Give it a thickness of 50 millimeters. And let's set a width of 400 millimeters. You can see everything updates as it should. Now let's set the thickness back to 18 millimeters. It's the thickness of the boards that I'm using. And now let's create the holes for the hinges. I'm just going to create one and then copy it on the other side, of course. So select the top face, click on the new sketch button, and here I have to draw 3 circles. If you're using different type of hinges, you might want to have a different sketch. And I have open here a sketch, drawing of what the dimensions should be. So I first see a diameter for this circle, an offset between the center of this circle and the 2 holes for the screws, and I would have expected to have a distance from here to the edge of the door, but I only have it from this little side here. Also, I need to set a depth for the hinge. So let's set everything up. Select the centers of these 2 holes and press H for a horizontal constraint. They always should be horizontal. But before setting the other constraints, I will close this sketch and go to the parameters to define the variables that we are going to use. I'm not going to set them up here, then create the parameters and go back to change everything because it's useless. So let's close the sketch. Now going to the parameters object, right click again, add property. Now I will change the group name to hinge. And the first variable is main diameter. Again, I'm using uppercase for each word, no spaces between the words. Click on the OK button. It's going to be length. I'm not going to change the type. Every value that I'm using in this project is going to be of type length. Screws diameter. Screws offset. Main offset, which is going to be the offset of the large hole. I also need the screws distance, which is the distance between the 2 holes for the screws. What I know is that they are symmetrical to this main hole, so I'm going to set that up also. And I also need an offset to the side, so I can modify the distance from the edge of the board where I drill the holes for the hinge. So right click again, click on add property. I'm going to place this value in the door parameters. So type in the group name again. You cannot select the groups from a drop down. Now let's give a name, which is side offset. One more thing that I need to add is the depth, and I'm going to place it again in the hinge group because it's the depth that defines the hole for the hinge. Now let's set some values for the variables that we have entered. The side offset can be any value. I'm usually using 100 millimeters. The depth for the hinge, as I can see in this drawing, is minimum 11.8 millimeters. I'm going to use a value of 13 millimeters just to make sure everything fits okay. The main diameter is 35. The main offset, again, I have to take a look at the sketch, and it should be between 3 and 5 millimeters. It depends on the thickness of the board. This time I'm going to use a value of 4 millimeters. So let's go to the main offset and write 4 here. For the screw diameter, I'm going to use 3.5 millimeters. The distance between the screws, let's take a look at the sketch. It's 45 millimeters. And the screws offset again from the sketch is 9.5 millimeters. So let's write it here. So now we have all the values determined. Let's go to the second sketch, the one that defines the holes for the hinge, and edit the sketch set constraints in order to have the correct positioning and hole diameters. First, let's set the diameter for the large hole. Press K, then O. Press equal to enter the expression editor. Parameters, main diameter. Press enter to close everything, or click OK, whatever suits you best. Now let's set an equal constraint between these two circles, so select them both, press E. Let's set the distance between the two of them. Select their centers this time, press L for a horizontal distance, press equal, parameters, and screws distance. What I still need to set is for these two holes to be perfectly centered with the bottom hole. In order to do that, I will create a new line. Make sure hovering the center point of this and having the icon for the point-on-point constraint, click on it, make a vertical line. If it doesn't have this small icon here, select it and press V for a vertical constraint. But I don't want this line to appear in the sketch, so select it and press this button, which will turn it into construction geometry. Now I will select in this exact order the centers of the two circles, and this point, press S for a symmetry constraint. Now, as you can see, I can only move everything together. I also know the distance of this line, so I won't be able to separate these two circles from the main one, which is, select it, press I for a vertical distance, press equal, parameters, and screws offset. Select either one of the circles. I have already created the equal constraint, so I only need to set one. Again, press KO to set a diameter, press equal, and use the screws diameter value from the parameters. And let's take a look at the sketch. I can move everything around. All the holes or all the circles are moving together. Now let's set this small distance here. So select the circles, select the bottom axis, the x-axis, and I can press KD or go to this little arrow and select this, which is constraint distance. As you've seen in my videos, I'm using a lot of shortcuts. If you don't know them, try to learn them along the way. You can see here next to each of the constraints, you can see the shortcut here. Try to practice them. It will make work much faster. So let's set a distance constraint. Press equal, parameters, and select main offset from the list. Click on the OK button. The circles are now correctly placed at the bottom. If I take a look in the solver messages, I still have 1 degree of freedom, and if I try to move the sketch, you can easily see that it's the movement from left to right. For that, to fix that, I'm going to select the center of the main circle, press L for a horizontal distance constraint, press equal, parameters, side offset. That's the name that I gave for this variable. You can see it is 100 millimeters, and now everything is green, which means, as you can see here in the solver messages box, fully constrained. We finished editing the sketch. Let's close this window and move on to creating the pocket. With the sketch selected, go to the pocket button, press equal to enter length based on the parameters that we have entered in the variable set, and here select depth, press the OK button, and let's take a look. I have everything exactly as I want it to be. One more thing that I want to make, because most probably I will have two hinges, is to mirror this pocket, these three holes, to mirror them on this side. In order to do that, I'm going to select the end of the board, the face from the end of the board. Click on this button to create a new datum plane. For now, I'm going to leave it just as it is. Click on the OK button, and I want to mirror this hole relative to the center of the board. In order to do that, let's go to the datum plane, go to attachment offset to position, and I want it to move on the x-axis half the length of the board. But I'm not going to change the x value, because these values here are relative to the coordinate system of the plane. Since it is sitting on this face, this will be its y, this will be its x, and in this direction that I'm interested is going to be the z of this object. So I need to modify the z. Let's press equal, press minus because I want it to move downwards, parameters, length divided by 2. Now let's press on the OK button, click somewhere else, and you can see the plane has been moved to the exact center of this board. Maybe a top view should be more obvious. And now let's make the mirror. Select the pocket, click on this button, make sure the pocket is selected, but since it's such a simple model, I don't have a problem with that. And I want the plane that is going to be the reference for the mirror to be the datum plane. I don't have it here in the list, so click on select reference, go to model here up, select the datum plane, go back to tasks. You can already see the updated view. Click on the OK button, and now I have the hinges equally symmetrically placed from the center of the board. I can now press space to hide the datum plane, and I'm ready with the modeling phase. Let's move on to the CAM workbench and see how to make the G-code, to export it to Universal G-code Sender and mill it on the CNC. I'm now in the CAM workbench. Select the door, click on the new job button, make sure the door is selected. Sometimes the checkbox might not be checked, make sure it is checked. Click on the OK button, and we will just make a few settings here. If you want more details about creating jobs, you can find a video dedicated to that, both in FreeCAD 0.22 and in FreeCAD 1.0 on my channel. So let's go to the Tools menu, click on the Add button, and I'm going to use the 3.175 end mill. Select it from the list, click on the Open button, and now I need to give it speeds for movement on the horizontal, which is X and Y, and on the vertical, which is Z. So double click here, and I'm going to use 3500 millimeters per minute on both directions, on X, Y, and on Z. Depending on the machine and the tool bit that you have, the material that you are milling, you might want to use different values. It's all up to your experience and what you know your machine can do. Also, it is of course connected to the spindle speed. In my case, it's going to be 19,000 RPM. I can now select the default tool, click on the remove button, and go to the output tab. Here I'm going to click on the three dots to select the file name to which I'm going to export the G-code for this operation. And now that I have the output file set, I can close the job. Everything is set up. As you can see, the origin is correctly placed. That is why I was telling you to make the door from the origin to the X, to the positive X and positive Y. Let's click on the OK button to close the job. And now that I have the job created, I need to make the operations, which is going to be just one operation, a Helix operation. So select the job, click on the Helix button, click on the Apply button, and I think that this might lead to a lot of useless milling time. Let's optimize things a little bit. The first thing that I'm going to change is start from outside to inside. The step over to 95%, I just need a lot of material removed. And I'm also going to change the step down. For that I have to move to the depth tab. So let's go to the step down. I cannot edit the value by clicking here, it is locked because it's based on an expression which is the tool diameter. I'm going to use a multiplier. Here's a multiply by 1.5 millimeters. This might sound a little bit weird, especially if you've seen my other videos where I prefer to use a very small step down and faster speed. This time I'm going to use a larger step down since it's a Helix operation. Everything works okay. I've tested it. Using a larger step down when creating Helix operations, especially in soft materials such as MDF, is a good practice to save a lot of time. So click on the OK button, and I've set everything that I need to set in this operation. I can click on apply again to update the G-code. You can see much less movement. It will be much faster. So let's click OK to close the operation, and then we will export the job. That is very simple. I've already set the file. I can go here, click on this button, post process, inspect the G-code if I want to, click on the OK button, and now save the file. I already have it created, so it will ask me to overwrite it. Of course, I will click yes, and the G-code is now saved. I can go to the workshop, open up Universal G-code Sender, and mill this door. So this concludes the video for today. It's a simple video, but a very useful video, especially if you're making cabinets, you have a CNC and you want to make everything as good as possible. Using this type of approach will help you make everything very fast, but at the same time very good, very precise, with all the dimensions there. And you can adapt this for any project by just changing a couple of values in the VarSet, the new feature of FreeCAD 1.0. Of course, you can use this type of approach with different programs if you're using a different program than FreeCAD. I'm using FreeCAD because, as you see in the name of the channel, I'm only using open source software to operate my CNC. Thank you for watching. Don't forget to subscribe, and if you want to support me through my Patreon page, visit it. You can find the link in the description. Thank you very much. See you next time for the next video.